Hey guys, so this is section 6.1, video 1. Okay, section 6.1, it's about composite function. We talk a little bit about composite functions in section 6.1. They're going back to that. So let me start with definition. Given two functions, f and g, the composite function is f composed with g. So you read f composed with g is defined by f composed with g of x, that's the input, is the same as f of g of x. So the first function from the left side, which in our case it's f, okay, that's the outside function. And inside, you see g of x, that's the inside function. So what we're going to do here, we're going to have two different functions, or sometimes they're the same, f and g, and we're going to create brand new function, which we call composition, f composed with g. How that's going to work? Outside function, which is in this case function f, you're going to replace the input of outside function with the equation of function g. Okay, and just give me a second. Resume. Okay, so let's see. Let's do the examples. Example 1. Evaluating a composite function. And again, you have a PowerPoint, you have also many examples in a textbook. So I like to pick additional examples. So you guys have more examples to practice. This is from your textbook, page 408, number 13. And they give you two functions, so this is what is given. They give you the equation of function f of x, which is equal to x, linear function, g of x, that's the second function, and the equation of g of x is 3x squared plus 1, quadratic function. And for the given functions, f and g, find. And this is what we need to do. And there's a, b, c. I'm going to start with a. F composed with g of 4. Okay, so let me show a solution for this one. Give me a second, because one class is taking tests. I want to make sure that everybody's good. Okay, so solution. How we're going to do it, and this is how I teach you, okay, because that will apply to the next examples. First, find the equation of the composite function, f composed with g. Okay, so f composed with g of x, by definition, you start with function f, and the inside function is the second function, which is g of x. Okay, so how that's going to work? F is outside function. So what you're going to do, you're going to copy the equation of outside function, which is 2, and where you used to have x, I'm putting x. Okay, so this is equation of function f. Okay, function f, it's 2 times x. Now look what happened. You're replacing x with the equation of function g. So where we used to have an x, we're going to put g. Okay, we're going to plug in equation of function g of x. So equation of function g of x is 3x squared plus 1. So we replace x of function f with the equation of function g, because function g is inside. So note f, lowercase f is outside function. Start with copying the equation of outside function, and outside function, it's always the first one on the left. So in our case, f of x, right? Then substitute the x from outside function with the equation of the inside function, which is again g of x. Okay, so inside function is always the second one. Okay, so what you're going to do next? Next, we're just going to evaluate. So let's simplify that. So we have 2 times 3x squared plus 1. We're going to distribute 2, and we're getting 6x squared plus 2. So this is our f composed with g. This is our composition function. So now we'll go back to the problem, and here they ask you, okay, evaluate f composed of g. Okay, this is f composed with g of x. Okay, now look what happened. You have to evaluate f composed with g when the input is 4. So f composed with g of x, we find the equation, which is 6x squared plus 2. Next, evaluate f composed with g, and we're going to replace x with input 4, because that's what they want us to do, of 4. So what you're going to do, you're going to substitute 4 where we used to have x. So that will give us 6 times 4, and I follow the equation of f composed with g, square plus 2. So where we used to have x, we plug in 4. So remember about order of operation, PEMDAS, so exponent goes first. So we have 6 times 16 plus 2, and that will give us 98. B. Next. Next, they asking you this. G composed with F of 2. So look what happened. In this case, G is outside function. F is inside function. So what I recommended, first create G composed with F of X, because that's what they're usually going to ask you. Just create the equation of the new composition. So G composed with F is the same as G of F of X. What that means, that outside function is G. You're going to start with the equation of function G. So let's go back. Equation of function G is 3x squared plus 1. But look what happened. Where we used to have x, okay, where we used to have x in function G, we're going to plug in f of x, okay? So equation of function f. Equation of function f is 2 times x. So I substitute x from function G, which is outside, with equation of function f. And function f equation is 2x. Okay, so we're getting 3 times 2x squared plus 1. Of course, you need to evaluate. So don't forget that the exponent is first. So we have 3 times 2 to the second power will give you 4. X to the second power, it's x squared plus 1. Multiply next, we're getting 12x squared plus 1. So G composed with f of x has the equation of 12x squared plus 1. Okay. So now I'm going back to the problem. They ask you to evaluate G composed with f when the input is 2. So G composed with f when the input is 2. What you're going to do, you're going to replace x with 2. So you're working with your equation, which is 12. And where you used to have x, you plug in 2. So 12 times 2 to a second power plus 1. We're going to evaluate that. So we're getting 12 times 4 plus 1. That will give us 48 plus 1. And this is 49. Okay, let me just check email, because that's the time when students taking okay, that was the time when students are taking a test, but it looks like everybody is fine. Okay, C. For C, they want you to evaluate f composed with f of 1. So what we're going to do first? First, create the composition f composed with f of x. So we have original function f and we plug in function f where we used to have x. So how that's going to work? F composed with f of x. This is the same as f of x. So f is outside and f is inside function. So how are we going to do it? This is outside and this is inside. Even if the functions are the same, it's still the same rule. So I'm going back and I'm going to check what is the equation of function f, which is outside. So the equation of function f, it's 2 times x. And where I used to have x, I plug in, I replace that x with equation of function f of x. Okay, which is again 2x. So original x of function f, it's going to be replaced with the entire equation of function f. So we plug in 2x. Okay, and multiply, we end up with 4x. So f composed with f of x is the same as 4x. Now we're going back to the problem. They want you to evaluate the value of f composed with f when x is equal 1. So f composed with f of 1, what we're going to do, we're going to replace x with 1. So we're getting 4 times 1, which is 4. Okay, so that was example 1. So I teach you how to create a composition function. We're going to practice more. Example 2. Example 2, it's similar. We're creating the compositions, but also what happened with example 2, we're going to talk about how to find the domain of composition. So we're going to, example 2, it's about finding composite function and its domain. So let me just write a note. To find the domain of the composite function, and I'm going to write this down using f composed with g, okay? But if you have g composed with f, we'll just switch the order. First, find the domain of the inside function, because the inside function become the input of the entire composition. So find the domain of inside function. In this example, inside is g of x. Okay. Next, create the composition, create the composite function f composed of g of x, and find the domain of the new function. Last, will be combine both domains, g of x and f composed of g of x. It's going to make sense if we're going to do examples. Okay, so this is the note, but again, let's see example first. So in this example, this is example 2 about finding composite function and its domain. I'm going to give you function f of x, which is equal x squared plus 3x minus 1 and g of x, which is equal 2x plus 3. So this is easy example. This is the example which also textbook explains. Later I will do a little more advanced example. So here what they want us to do, A, okay. In A, what they want us to do, they want us to create a composition f composed with g of x and find the domain. And find the domain. of f composed with g of x. So first, again, create f composed with g of x. Okay, so f is outside, g is inside. So what you're going to do, f is outside, so you're going to copy the equation of function which is outside, which is f. So it's x squared, and where I have a x, I'm just putting backs because we're going to do the substitution. So it was x squared plus 3x minus 1, and where we used to have a x, you're going to put equation of function g, where we used to have a x. Okay, so equation of function g is 2x plus 3. So where we used to have x, we plug in g, 2x plus 3, 2x plus 3. Okay, don't forget about when you substitute, put everything in parentheses. So now we're going to evaluate. So f composed with g of x equal, so let me simplify that. You have 2x plus 3 to a second power, which is the same as 2x plus 3 times 2x plus 3, plus, and here I will just distribute. 3 times 2x will give me 6x. 3 times 3 will give you 9, minus 1. So let's FOIL here. So we're getting 2x times 2x, which is 4x squared. Oh, outside, which is 2x times 3, that will give you 6x. I stands for inner, which is 3 times 2x, that will give you 6x. L stands for last, 3 times 3, that will give you 9. Plus 6x plus 8. 9 minus 1 gives you 8. Simplify, so we're getting 4x squared. Let's add all the x's together, so 6x, 6x, and 6x, so we're getting 18x plus 9 plus 8, which is 17. So this is our composition. This is our f composed with g of x. So we have a composition. Now they want you to find the domain. Next, find the domain of f composed with g of x, which is the function 4x squared plus 18x plus 17. So the notes which I gave you, like you guys see inside, it's function g. Okay, so first find the domain of inside function, which is of g of x. So let's go back to the equation of function g. G of x, this is linear function. Linear function domain, it's all real number. You can plug in any value for x and you always will be evaluate function. So this is linear. So domain of g of x is all real, which means from negative infinity to positive infinity. Next, find the domain of the composition, which we just create. So domain of our composite function right here, without graphing, but let's just quickly talk about it. This is quadratic function. So there's no restrictions for x. You can evaluate this function for any x values. So domain of composition function, which is f composed with g of x, is also all real, which means from negative infinity to positive infinity. So last, combine step 1 and step 2, first and second domains since we have for both all real numbers, so the answer will be all real, which is from negative infinity to positive infinity. Okay. Okay, so that was A, not bad. Let's do part B. So it's the same type of problem. Technically here we're teaching you how to find the composition function, and we adding the domain. In part B, they want you to find the equation for the composite function g composed with f of x and its domain. Okay, so let's start it with creating composite function. So g composed with f of x, g is outside, f is inside. So you're going to start with outside function, which is g. Copy equation of function g. Function g is 2x plus 3. 2x plus 3. Like you see, I'm not copying x because what you're going to do, you're going to replace x with the equation of function f. And function f has the equation x squared plus 3x minus 1. X squared plus 3x minus 1. So always remember about parentheses. Okay, so like you see, f, which has the equation x squared plus 3x minus 1, replace x from function g. That's how the composite function works. So let's simplify. Here, you just need to distribute 2 to each. Okay, hopefully you guys can see it. So that will give you 2x squared plus 6x minus 2 plus 3, which is 2x squared plus 6x plus 1. 2x squared plus 6x plus 1. So g composed with f is 2x squared plus 6x plus 1. Okay. And now we have to find the domain. Next, find the domain of g composed with f of x. So again, you cannot just go back to your final product and just verify the domain of this function based on this equation, because don't forget that you create a composite function. So technically, the x of composite function was substitute with function g. Was substitute with inside function, which is function f. That's why for the domain, first, you always have to find the domain of inside function because that's the one which we plug in. So find the domain of inside function. So in this case, inside, it's f. So function f, quadratic function, domain of quadratic functions always all real. So domain of f of x, it's all real, from negative infinity to positive infinity. Next, find the domain of composite function. That's the one which we just create. Our composite function, it's also quadratic equation. So domain of quadratic equations always all real. So it's also all real, which means from negative infinity to positive infinity. So last one will be combining both first and second domain since we have easy example, everything is all real, so we'll have all real from negative infinity to positive infinity. Okay, next what I'm doing, what I will do, I will go over example from the textbook. Maybe I will skip some of them. I will just do A, B, C. So similar problem. So this is the example this is the problem from page 409. That's problem 29. So they give you two functions, f of x equal 3 over x minus 1, g of x, it's equal 2 over x, okay? And they give you parts A, B, C, D. Let's start with A. They want you to find f composed with g of x. So find the equation and its domain. Okay, so let's do it. First, create a composition. F composed with g of x. F is outside, so I'm going to copy the equation of outside function. And where I used to have x, I'm putting the square because we're going to do the substitution. And g, it's inside function, so you replace x with equation of function g, which is 2 over x. Okay, so now you need to simplify that. Okay, so you have 3 over 2 over x minus 1 over 1. So let's just do it that way. So what you will need to do, here we have fraction minus fraction, which means you need common denominator. Since you're subtracting 1, so this is the easiest way to find the common denominator. The common denominator will be x. Okay, so you multiply 1 and 1, top and bottom, by x times x times x. I'm creating that common denominator. So we're getting 2x minus x over x. So like you see, we create equivalent fraction. We're not changing anything. Now when we have a common denominator, let's simplify. So we're getting 3 over, copy denominator, subtract your numerator. So you have 2 minus x. And simplify more. Now you have fraction divide by fraction, which means keep, change, flip. Keep, change, flip. Keep your numerator, which is 3. Change means change division to multiplication. Flip the bottom part, so you'll end up with x over 2 minus x. And now you have number multiplied by fraction, so you multiply numerator by 3. So that will give you 3x over 2 minus x. So this is our f composed with g of x. We have it. Okay, so this problem more advanced. Okay, now let's talk about finding the domain. Find the domain of f composed with g of x, which is 3x over 2 minus x. So use the steps which I gave you. First, find the domain of the inside function. So inside function is g of x, right? So we have to find the domain of g of x. Look up on the equation of g of x. G of x is equal to 2 over x. So g of x has the equation of 2 over x. This is rational function, okay? So domain it's going to be all real numbers except 0, because you can never ever divide by 0. So domain of G, it's all the x's except 0, which, I'll just put it that way, all real numbers except x equals 0. So that's the domain of G of x. Second, find the domain of the composite function. Of course, we need to find it because that's the one which we just created. So composite function f composed with g, which is 3x over 2 minus x. This is also a rational function. So to find the domain of rational function, again, you take your denominator and you just saying that denominator can't be equal 0, because that function won't be able to evaluate. It won't have sense to solve it for it. So solve for x. I'm going to add x to both sides, and we're getting 2 can be x, which is the same as x can be 2. So here, the domain will be of f composed with g is all real numbers except x equal to. And the last step will be combine first and second step. Combine the domains the first and second domains. Okay, so from the first step, we got the domain, it's all real numbers except x equals 0. So first step, we got that x can't be 0. From the second step, we got that domain, it's all real number except 2, which means x can't be equal to. So you combine them together. So the answer will be all real numbers except x equals 0 and x equal 2. Okay, if my MATLAB will ask you for interval notation, which I also a huge fan of it. So I always recommend it to draw the number line. This is your x values. We can't have 0 for x, okay? And we can have 2 for x. So technically the domain, it's all real numbers except 0 and 2. So we're going to write the intervals from negative infinity to 0, union 0 to 2, union 2 to positive infinity. And I will do one more. I'm not going over every single problem from this question. I will just do maybe f composed with f. So this is C. The same example, C. They ask you to find f composed with f and its domain. So first what we're going to do, we're going to create that composition. So f composed with f of x. That means this is the same as f of x. So outside its f, let's copy equation of function f. Function f has the equation 3 over x minus 1. And like you see, where I used to have x, I'm plugging in entire equation of function f. So function f, it's 3 over x minus 1. So on a side, let me just put it that f of x was 3 over x minus 1. Okay, so we plug it in. 3 over x minus 1. And of course, you need to simplify. So f composed with f of x equal. Okay. Just give me a second. Okay, so f composed with f of x. Let's simplify that. So we're having 3 over x minus 1 minus 1 over 1. So you can put it that way. So the same idea, you need to create a common denominator. So the common denominator is going to be x minus 1. So you always take two denominators, you multiply them together. Since x minus 1 times 1 will give you x minus 1, so I multiply the second fraction, 1 over 1, top and bottom, by x minus 1. Okay. So that will give us 3 over x minus 1 minus x minus 1 over x minus 1. Okay, let's simplify that denominator. So we're getting 3 over x minus 1. Now, since we have common denominators, so we're going to combine numerators together, minus x minus 1. And let's distribute that minus. So we're getting 3 over 3 minus x plus 1 over x minus 1, which is the same as 3 over 3 plus 1 will give you 4 minus x over x minus 1. And the same idea here, keep change flip, keep the top one, which is 3, change division to multiplication, flip the second fraction. So that will be x minus 1 over 4 minus x. And now number multiplied by fraction, you only multiply numerator by 3. So that will give you 3x minus 3 over 4 minus x. Okay, so this is f composed with f. We have it, of x. Okay, you home. Now we have to find the domain. So I'm not going to write the steps, but I explain it to you that first domain from inside of inside function. I'm going to write down the steps. So inside function, it's f. Function f, it's 3 over x minus 1. That's the inside function. Rational function, so how you find the domain? You take your denominator and you're saying that it can't be 0. Solve for x, you're getting x can't be 1. Let's save that. Second domain of the composition. So our composition function is 3x minus 3 over 4 minus x. Also rational function. So domain of rational functions, you take denominator and you're saying that that can't be 0. Solve for x, and we're getting that 4 can't be x, which is the same as x can't be 4. And the last part, you're going to combine those two. So we have that x can't be 1 and x can't be 4, okay? So the answer, again, if that would be your next test, just open responses, you always can say it, all real numbers except x equal 1 and x equal 4. Now, let's practice interval notation. So for interval notation, again, I recommend it to just draw the x-axis. You can't have 1 and you can't have 4. So the domain, it's any real number except 1 and 4. So the interval notation will be from negative infinity to 1, union 1 to 4, union 4 to positive infinity. Okay, so I'm going to stop here, and I will record for you guys the second video with 2 more examples, and there's some stuff which we need to talk about it.